This is a nice way to demonstrate the fundamental cause of chaos. We have a little pendulum with a magnet on the end of a rod. We release it, and it undergoes a very complicated motion because it is interacting with 3 fixed magnets glued to the base. The fundamental cause of chaos is basically this. When the magnet approaches the fixed magnet, it can go either to the left or to the right. Which way it goes depends very sensitively on exactly where it is when I release it. Similarly, at any other point along its trajectory, which way it goes will depend on exactly where it happens to be at any particular moment. That phenomenon, sensitive dependence on initial conditions, as we call it, is the fundamental cause of chaos. It arises from the underlying nonlinearity of the equations describing the motion. The entire universe is filled with fluids in turbulent motion. The atmosphere, the oceans, much of outer space, it basically is turbulent fluid. So one could take the point of view that you don't understand anything about the world until you understand turbulence.
For a while, this trail of cigarette smoke rises in a simple stream. Suddenly, there's a transformation. It becomes turbulent, chaotic. But what rules, if any, govern this sudden transition from order to disorder? Gollub, with a partner, Harry Swinney, built this cylinder to drive fluid from simple flow to turbulence. Inside is a smaller cylinder, which can rotate at different speeds, putting an increasing shear force on water which is contained in the narrow ring around the outside. Small translucent particles suspended in the water allow us to see structure when it emerges. They start by rotating slowly.
As we increase the speed of the fluid, you will see the emergence of a pattern, emergence of horizontal lines that mark the boundaries between donut-shaped vortices. These donuts are stacked along the direction of the cylinder, and we can see them now as they start to form at a very well-defined rotation rate of the cylinder.
Water is rolling in a spiral motion sideways and up and around the donuts. As they increase the rotation rate to a well-defined level, these wavy lines develop. A subsidiary fluid motion has superimposed itself on the first, moving at a different speed. As they increase speed further, there is an abrupt change.
Okay, we've increased the speed here, and we see now for the first time the emergence of disorder, emergence of chaos in the flow. If you look on the small scale here, you can see the irregularities that mark the appearance of this disorder. The rotation rate at which this disorder appears is very well defined, just as the previous transitions were it happened at very well defined rotation rates.
The flow around the donuts is switching erratically to and fro, creating a chaotic, turbulent interference pattern at the border between donuts. When you drive natural systems into chaos, they all follow a very similar route. Apply energy to a system